In this video, we're going to take a look at how we can count different numbers of items. In the first example, it says we want to order a sandwich and a drink at a local store, let's say like a Subway or a Togo's. If they offer 5 types of sandwiches and 3 drinks, how many different combinations can we order? So we're just going to list out the different ways that we can create sandwiches. First of all, we just basically have 5 sandwiches, so I'm just going to label it 1, 2, 3, 4, 5. Imagine you have like a, I don't know, let's say like a ham, a roast beef, a meatball sandwich, a veggie sandwich, and let's say pastrami sandwich. You got 5 different kinds of sandwiches. And the store has 3 types of drinks. Maybe you can get like a soda, maybe you can get water or juice. So with each of the different types of sandwiches, we're going to create a tree diagram saying we have the 3 options: soda, water, juice. Soda, water, juice. Soda, water, juice. Oops. Soda, water, juice, and so on and so on and so on. Yep. So, oops, I wrote that the wrong way. So, basically it's the idea of like, let's say on Monday, maybe we get a ham sandwich with a soda. Maybe on Tuesday we get a ham sandwich and a water. On Wednesday we get a ham sandwich and a juice. On Thursday, maybe we now get roast beef and soda. On Friday we get roast beef and juice, right? So, and so on and so on. You can think of that as how many different ways can we get a different menu combination. And you can see here, if you look at all your tree diagrams, you have 3, 6, 9, 12, 15. So we have 15 different combinations. Well, hopefully you're also able to see, how do we actually get that 15? Well, you had 5 sandwiches and 3 drinks. We're using what is called the multiplication principle. The multiplication principle basically just says, you take the number of items for choice 1, you multiply that by the number of items in choice 2, and so on and so on. You can multiply that by the number of items in choice 3, and it just keeps going. You basically multiply your values together. That's the multiplication principle. Okay, the same thing can be applied to, let's say, example number 2. We can say, how many ways can you line up a class of 30? So just imagine I drew 30 people here. I'm not going to draw all 30 because obviously that's just way too much. I'm just going to draw a number of stick figures here, and you can kind of interpret that as I have 30 students. Okay, so what I'm going to do is I'm going to say, okay, if we need to line up 30 students, we have, here's the first person in line, the second person in line, the third person in line, and it just keeps going. Now for the first person in line, of the 30 students, I can pick any one I want, really. And so I have a choice of 30 students to pick in line 1. Okay, let's say I have now picked that person. Well, now that he has or she is in line 1, in the position of 1, then in the second position, I can pick anyone else. How many students do I have to choose from? I have 29 more students to choose from. And so let's say I pick someone else, right? And then in the third position, I now have 28 students to choose from, and then 27, and so on and so on and so on, until when you reach the end of the line, you really just have 3 students to choose from, right? And then you have 2 students to choose from, and then you have 1 student to choose from at the very end of the line. So you can kind of think of this like a big tree diagram. You've got all those 30 people, and then after that you then have 29 people to choose from, and then after that you have 28 people to choose from, and so on and so on. So in a way, you're almost creating this tree diagram where you're multiplying all of those values together until you reach your value of 1. Okay. Now in math, you can see here, it would be way too tedious if I wanted to write down 30 times 29 times 28 all the way until 1. And so we have this thing called a factorial. And the factorial allows us an easy way to write what I just wrote up above. And it looks kind of complicated right now. So how do we write it in an easier fashion? We use this exclamation point. Now, we're not yelling it out. We're not saying n, right? What we're really doing is n factorial, that should be a lowercase n, by the way, really just means let's take that number n, multiply it by the next integer down, multiply that by the next integer down until you reach your value of 1. Okay, so that's basically what this is saying. This is the same thing as saying 30 factorial. And let's go ahead and find that value. Now, I wouldn't expect you to multiply that by hand. We can use our handy dandy calculator here. I'm going to go ahead and get out my graphing calculator. And what we're going to do is we're just going to type in 30. And the way we can enter in factorial is by pushing the, let's see here, the math button. Okay, and the math button is just below the alpha. And then I'm going to go to the right until I select probability. And you can see here that the exclamation point is probability item number 4. There it is. That's our factorial symbol. So I'm going to go ahead and push enter. And now it says 30 factorial. I push enter again. And there's my answer. I have 2.65 times 10 to the negative 32nd. You'll notice there's an E there. Times 10 to the negative 32nd power number of ways that we can get 30 people in a line. That's quite a bit. Okay, so 2.65 times 10 to the 32nd number of ways. Wow, that is a lot. Okay, so let's take a look at another way that we can count the number of items. I'm actually going to go now to the next page. And let's take a look at problem number 4 here. I'm actually going to focus more on C. Once you see item number C, hopefully you can do the ones that are above as well. What's this asking? Given 0, 1, 2, 3, 4, 5, how many 4-digit numbers can be formed if digits cannot be repeated and the number must be even? So if the digit cannot be repeated, then that's basically saying I can't have a number like 5,555. Okay, because one, it is a 4-digit number. However, because the 5 is being repeated, that is eliminated from this particular problem because we're saying that it cannot be repeated. Okay, so you'd have to have a number like 5, 4, 3, 2, or maybe 1, 2, 3, 5, things like that. Okay. Oh, wait, and don't forget the second criteria. It also needs to be even. So actually the numbers I chose earlier don't work because in order for it to be even, think about what even means, right? And think about the choices that you have here. What must that mean? Well, that must mean in order to have an even number, I need a number like, let's say 2,000, let's say a number like 1,342. In order for it to be even, I would need like a 2 there, right? Or maybe I might want 1,340. I have a 0 there. If it's a 0 at the end, I know that's an even number, right? Or maybe I want that 4 to be switched. Maybe I really just need the 4 at the very end as well. So you can see here that in order for you to have an even number, you need to see that the last digit is either a 0, if the last digit is 0, or maybe if the last digit is 2, it could work. That would be even. Or, and I'm just writing these ors again, and I'll put it in boxes just so that what I'm really doing is I'm kind of like separating these particular instances. Okay, or maybe the last digit is a 4. Right? Those are the possibilities that we can get an even number. Now we need these to be 4-digit numbers, so I'm just going to go ahead and say, hey, I have 4 slots to fill. I know my last digit has to be a 0, right? Because this is 0, I really only have one choice that can fit in this spot here. Also, because the digits cannot be repeated, okay, if I'm taking a look at how I have already used the value of 0, then really I only have these 1, 2, 3, 4, 5 numbers to choose from. So let's say in the first spot, I really have 5 numbers to choose from, right? So I can choose numbers 1 through 5. And so therefore, if I have 1 through 5 in here, then I have 5 numbers to choose from there. But now let's say, okay, one of those numbers get used up, and I'm just going to go completely random here. Let's just say we use that number. Well, then if you used a number, then you would only have like numbers 1, 2, 3, and then the number 5, because maybe we used the 4. Well, if that's the case, really what we're trying to say here is now you only have 4 spots to choose from, 4 numbers to choose from. And then maybe because we selected a number, let's say we selected 3, again, just purely random, then now you see here that we only have 3 numbers to choose from. So what I'm really trying to say here is that, you're basically saying we got 5 numbers to choose from, multiplied by 4 numbers times 3, and then finally you only have that one choice because we know that last number must be a 0. Okay. Now, those were the number of even numbers in which we had a 0 at the end, but we also had the case where we could have a 2 at the end. So I'm going to do the same thing. Now I know that this number at the end must be a 2. It must be a 2. Now because it has to be a 2, you only have one choice again. It has to be a 2 at the end. However, now that we are saying that, okay, now 2 is being used up, what other numbers do we have to choose from for, let's say, our first number here? Now this is going to be a little bit different from our first example in that one thing that you know is that you have a 4-digit number. Now in our first case, it said we had 5 choices to choose from because we had 1 through 5. But now if you actually think about it, what numbers can you use? You can use 5, you can use 4, you can use 3, you can't use 2 because 2 is in the last spot. You can use 1. Can you use 0? If there's a 0 there, I don't think this is a 4-digit number, right? If there's a 0 there, then technically, what you're really saying is maybe something like this, right? Or rather, it had to be a 2, right? Maybe something like this, but that's not a 4-digit number. Technically, this is still just 342. And so for that reason, you actually can't fit a 0 at the end. So how many choices do you have? You really just have 4 choices to choose from when it comes to that first number. Okay? Now, in addition to that, okay, so we've used the 2 at the very end, right? And then we use another number. Let's say we use a number like 5. Now, how many choices do you have in the second spot? Well, technically, now you can kind of put the 0 back in because remember, the 0 just can't be on the very left. Otherwise, you wouldn't have a 4-digit number. But you can totally have a number like 3042. Right now, the 0 can actually be put in that middle area. So if we actually put that 0 back in, and then you have the other numbers, again, you still have, think about how many choices you have. You have 4 choices to choose from still, okay? Because you added the 0 back in. Okay, and now let's say you use another number. Let's say you use the actual 0. How many choices do you have now? You have 3 more choices to use in that spot. And just like the last scenario, we can multiply those up to actually get how many numbers actually have a 2 at the end and is also a 4-digit number for that case. Okay. Now as we go to the next case, the last digit must be 4. So again, we'll draw 4 digits. We need this number to be a 4. So absolutely, you only have one choice to fill in that spot. It has to be a 4. And then in the other cases, okay, if we already have used our 4, you have how many choices for that first spot? Remember, it can't be 0, but it could be everything else, 1, 2, 3, 5. And since that's the case, it looks like we only have 4 choices there. Now, let's say you use one of them. However, you can put a 0 back in. Remember, you can have a number with 0 inside as a middle term, which means you again have 4 choices to choose from. You use one of those choices up, and then you have 3 choices to choose from. And again, you multiply. Now what do we say? Well, if you have all the choices in which the last digit is 0, we have 5 times 4, 20 times 3. So we have 60 ways of getting an even number with 0 at the end. Or you have 4 times 12, so we have 48 ways of getting an even number with a 2 at the end. Or we also have another 48 ways of getting a 4 at the end. So basically, if we have all these choices, 60 choices, or 48 choices, or 48 choices, when you see the word or, it's telling you, oh, we're actually adding all of our choices together. 60 plus 48 plus 48. And that's going to give us a total of 156 ways that we can get a non-repeating and even 4-digit number. Okay. Let's finish off the rest of this lesson in a new video.